All right, so we have an example from the practice final, which is also like an example from the book. Let's see what we know. Statistics students believe the mean score on a first statistics test is about 65. Instructor thinks the score is higher. So the statistics students are making a claim, and they're claiming it is 65. So right away, I have a mu from that first sentence equals 65. Since this is an equals because of the is, this would have to be the null hypothesis. So H0 is mu equals 65. The instructor thinks the mean score is higher. So the instructor says, I don't think so. I think it's greater than 65. So that would have to be the alternative because it does not have an equal sign in it, right? It's just a higher, which math symbols would interpret as a greater than. So this would be my alternative, which I was asked about. And then I'm going to start my sketch right away. And the sketch is going to help me determine whether I reject or fail to reject to make sure I put stuff in the right spot. So the null hypothesis mu always goes in the middle. That's 65. Since this is a small sample and I wasn't given the population standard deviation, this is going to be a t-test. And I can do some of this in StatKey, and I can do some of it in the one of the spreadsheets that we had from before. 5% significance level for a right tail test. So these are all the notes I write to myself when I'm doing one of these. So on the test, write all this stuff down, right? It frees your brain to make sure you're on the right path. So right tail, so that means that alpha in green, is somewhere over here. So alpha represents the number of other samples of 10 students that might happen that are out on this right side. So alpha is 5%. Okay, the t, we choose a t statistic for two reasons. One is if you do not know the population standard deviation, do not know sigma. And sigma, again, is the population, oh, my pen went freaky, standard deviation. And the other reason we use it is for a small sample size. So if n is less than 30 for the sample size. And I meet both of those conditions because nowhere in the problem does it say, hey, the standard deviation of first tests for statistics happens to be 5, right? It doesn't say anything about a population standard deviation. And then this is only 10 students. And then even if you did know the population standard deviation, if there's a small sample size, you probably should use a t anyway. And even if it was a big sample and you did know sigma, then you would still probably use a t anyway. So the t is like the usual distribution for most hypothesis tests for a mean. And again, mean, not a proportion. Proportions are different. So that's why I'm choosing a t. And then I also threw hints on this problem. So if you look back, down here it says the test statistic is a t. If it said a z, that means I would use a normal distribution, but this definitely says t. So that was a hint down there. Back to my notes. And then we can find the t value that goes with this. So the mean is always t equals 0. And then there's this number on the right here I could calculate that's called the critical value, and that comes from alpha. So just note, and I've been skipping this, but the book goes over it. Critical value is a t-score based on that 5%. So this was 5%, so it would be called t.05. And we could calculate that with what's called the t-inverse formula. Or we could use StatKey to figure it out. And the t-inverse would want to know what's that tail probability, and then the sample size minus 1. So I would have 10 minus 1, or 9 right there. But I'm going to get that number just for fun from StatKey. So for StatKey, your only choice for t's is the theoretical t distribution down near the bottom. And it wants to know df means degrees of freedom, or what's the sample size minus 1. So for me, that's a 9. And then since this is a right tail test, I just put my alpha up here. Mine was 5%. So it says if your data, your sample has a t-value greater than 1.8-ish, then you should reject the null. If your t-value from the data is less than 1.8-ish, you should fail to reject, is what that number tells me. So 1.833. And sometimes I give that to people on problems if they want it, but I didn't pre-calculate it for you on this one. But I think there were some other ones where I did pre-calculate it. Let's see. I give it here. I swear I did on at least one of these. Well, I didn't. Interesting. Okay, back to this one here. In a minute, I'm going to need this data in my spreadsheet. So I'm going to copy that. We'll get the spreadsheet out in a sec. And I'm just going to label that this right here is t equals 1.833. So the next thing I need to do is I need to find what is x bar from my data and what is s from my data. So then a spreadsheet is probably a good thing to get to next. And in my Google Drive, I have saved a version of that hypothesis test spreadsheet. So I called mine Carrie's hypothesis tests. And that's not the version I want. I want the Google version, not the Excel version. Sorry about that. That would be this one. So go find your version of the hypothesis test spreadsheet. It was originally called Hypothesis Tests 1. And if you're not sure how to find that, let me know that too. And again, your data will be different than mine, so we're going to have slightly different numbers. Okay, so once I get my hypothesis test sheet open, I want to choose the right tab, and I'm doing a t-test. Mine has an extra tab because I was messing around. And then the question was, were we given the sample data or not? So this first side of the sheet says without sample data, and the right side says with sample data. So I'm going to scroll over to the right of the t-test tab. And enter my information. All right, so let's see. My mu was 65, so I put that here and here. And then this is just for looks, but I'll put a greater than there. And make a note to myself, this is a right tail. And my alpha, this is just for looks, the computer doesn't actually use it. Mine was 5%. And then I have to get the data in here. So I got a bunch of extra stuff here. I'm just going to delete all this extra stuff. And if I'm not going to paste the data right here yet, because it's going to come in horizontal, and I want to get it to be vertical. So what I do is I recopy it or cut it, Control X on my keyboard, and then go to where I want it to be. So instead of retyping them to be vertical, there's an option called Edit, Paste, Transpose means flip rows to columns or columns to rows. So that saves me the problem of retyping and accidentally mistyping one of these numbers there. And so mine starts with 64.3 and ends with 85.5. Yours pasted wrong. Okay, so to double check how to paste this right, and it depends on the browser too sometimes, what browser you're using. It pastes one big number. Okay, so that means you highlighted too much stuff. So when you use your mouse on the screen, you want to be really careful to just barely start on the edge of the first number and just edge and right at the edge of the last number. So don't let go of your touchpad or mouse until you just barely grab that last number. Then Control C to copy. And then hopefully when you go back here, Control V for paste works. Okay. Is that any better? Yep, okay. sec. All right. So again, once you get it in horizontally, if you don't want to have to retype each number to get it vertically, so I'm just going to delete these here just to demo that again. Re-highlight your numbers if somehow they're not highlighted. And then I usually do a cut, so Control X, and then edit. Oh, you got to click on the right spot for it to be. And then edit, paste special, paste transposed. And Excel does this too. And then it'll switch the row to a column is what transpose does, or vice versa. Otherwise, you got to retype them in this column. And the computer is set, so for the sample mean, size, and standard deviation, it's looking in column R here for data. And once you put it in there, it says, oh, okay, here are your statistics right there. And it doesn't matter if I have extra numbers there. It only matters what's in column R. Okay, so then what do I know here? I know the mean is 70.92. There were 10 of them, and the sample standard deviation is 9.8. The central limit theorem says you got to tweak that by dividing that by the square root of 10. And that's what happens here. This is what's called the standard error. So sometimes I label that S.E for standard error. And that standard error is the number that helps me draw my picture properly. So I'm going to say it's about 3, and and 65, remember, was the center from the null hypothesis. And then this is about 71. And your data will be slightly different. And when I draw my picture, I sometimes overround here just to make it easy to draw. So back to my picture. Often when I draw my pictures, I mark off 1 standard deviation to the right. Let's see, so 1 standard deviation would be about here. I think 2 would be, oh no, I didn't draw that right. If that's t equals 1.8, 2 standard deviations would be out here more. 1 standard deviation on my picture would be about right here. 3 standard deviations would be out here. So my S was again almost 9. Yeah, 8.89 divided by the square root of 10. The square root of 10 is close to 3. So 9 divided by 3 is about 3 for the standard error. And that's how you scale your axis. So that means 1 standard deviation to the right is about a score of 68. 2 standard deviations to the right would be, what, 71-ish. And 3 standard deviations to the right would be a test score of about 74. My sample X bar ended up being about 71. This was about 9, and my standard error is always the S over the square root of n. So mine was 9 divided by the square root of 10, which is about 3-ish. Mine was really 2.8, but I'm just making it easy for me to draw. And then the question is, well, where does my mean land? Well, my sample mean about 71 lands about here. So that's about X bar right there. So my p-value then is from here over. So whatever this is going to be my p-value. And the test statistic is the t-score based on your mean. So the test statistic is a t-score in this case, and that would be X bar minus whatever the null hypothesis says divided by the standard error. And the spreadsheet calculates that. Hopefully your version does. I think the first version I published didn't have the t-score calculated for you. So could you check right now on each of your spreadsheets, do you have a row 19 that says test statistic? All right, good. Eileen, you okay over there? Holler if you have a question. So my test statistic is 2.1, so that means given that we expected an average score of 65, but we got a sample of size 10 with a score of about 71, that means we are about 2.1 standard deviations above the expected average. And that leads to a right-tailed p-value of about 3%, which is relatively small. It's definitely less than 5%. So I mentioned earlier in this that when I take my alpha and I use it to calculate a t-score, that t-score is called the critical value. So I calculated that to be about 1.8-ish. In this case, since it's a right tail test, anything to the right of that is in the critical region. So if your sample data falls in the critical region, that means you get to reject. So the critical region is also the rejection region. So I have one piece of evidence because my sample data fell in that critical region. So that says, hey, you should probably reject. And the other thing is I have my p-value, which is about 3%, which is definitely less than alpha, which was 5%. So this also says reject, please. So I have two pieces of evidence, and if you did your test right, your data landing in the critical region should match the fact that alpha is less than the significance level. So both of those say reject the null. So then to answer the questions here, the spreadsheet values you need are, we were asked for the sample mean, which is mine is 70.92. We were asked for the standard error, which is the standard deviation for the distribution of sample means. And then we were asked for the t-score for the data and the p-value. And then to make a decision, then we'll write a conclusion because that's good practice. So I need all of those. Let me move this out of the way to see if I did it right. And I'm pretty sure I did it right. The only way I could mess this up really was to maybe miscopy or mistype these numbers because the spreadsheet pretty much calculates everything. The alternative hypothesis, again, is based on that greater than, because the instructor thinks the score should be higher than 65. So that would be, for me, this one. My sample mean was 70.92. My standard error was about 2.8-ish. This says use 2 decimal places. So where did mine go? 2.81 was mine. Yours will be a little bit different. My test statistic was about 2.1. It says 4 decimal places, so 2.1055-ish. And again, you got to look at yours. So that's my t-score from the sample mean. And I had a p-value of about 3%, 4 decimal places. I think that was about mine, and that's smaller than my significance level, so I should reject the null and hopefully draw a picture. Yeah, I get it right. Hopefully yours went okay. As far as stat key goes, the only thing I can really do in stat key was like I did here, I could calculate the critical value. I could also calculate the p-value if I know the t-score. So again, my t-score based on the data was that x bar minus mu over the standard error, and mine came out to be 2.1-ish. So if I go over to stat key and I enter that t-score, and I still have a sample size of 10, so my degrees of freedom is 9. So I would enter my t-score down here, which mine was about 2.1055 if I go with the 4 decimal places. And it says, okay, your p value would be about 3.2%, which is about what the spreadsheet told me. And that's about all stat key can do for us. We would have to go elsewhere, like a regular calculator or the spreadsheet, to find this particular t-score. And to find that t-score, we also need the mean, the sample standard deviation, and the sample size. So like a more full version of that test statistic here. if you weren't using a spreadsheet, is you would have to find that mean somehow, find that standard deviation, and then the t-value would be, again, x bar minus the null divided by parentheses s over the square root of n is how I calculated that test statistic t-score. And for t-scores, you have to make that calculation for t-tests. All right, what else should we do? Oh, Eileen, I wish you said that earlier. Okay, so the question is, where's that darn spreadsheet? So the spreadsheets I introduced last week. So I'm gonna leave this page. So in week 9, I gave out three different spreadsheets. 2 of them are listed under model confidence interval with spreadsheets. Now we're not doing a confidence interval, so further down it says model hypothesis test with spreadsheets. So you got to go to the course homepage, then week 9, and then I have that pre-built spreadsheet here. So I'm going to open this up in a different window. And then if you're a Google user, then you would need to sign into your Google account if you're not already. So let me just sign in here for fun. So I don't know my password to that Google account. Let's try this one. If you're an Excel user, you have to download it. What's my phone? Hang on one sec. Okay. Getting there. Yes, it's me. Are you a Google user, Eileen, or an Excel user? Both. Okay, so then you can take your pick. If you're signed into your Google account, then you should have the option here to open with Google Sheets. And if you're an Excel user, then you would go to the right and download it to get it into Excel. And if you use Office 365, you would have to download it to your computer first, then upload it to Office 365. And then let's just make sure this is the right version of the sheet. I don't want to take a tour. Thank you, Google. Oh no, this isn't the right version. Shit, how did that happen? I thought I fixed this. Doesn't have the t-score. Oh, this one has a proportion. I put it in there. Let's see, t-test. I put it in there. I didn't put it in for the z-test. So if you want to, do you have this open yet, Eileen? Yes, okay, so I would recommend making the following change. So in the z-test, we should add a place to put the test statistic, and let's insert a new row here. So go to row 19. So I'm on the z-test tab, p-value, row 19. I want to, oh, I don't have the version I can open. Hang on. Oh, so the other thing you need to do is if you can't edit it, you need to make yourself a copy. Or save it as a Google Sheet. I'm going to go for save as a Google Sheet. And then I should be able to go down to the z-test row 19 and add a place for the test statistics. So p-value, I want to insert a row above that. And then here is where I'll put the test statistic. And it is a z-score, so I'll write z equals, and then in the next cell, I'll put that calculation. And the calculation is always parentheses for the numerator. Take your sample mean and subtract the null hypothesis mean. Close that subtraction and then divide by the standard error, which is in row 18 here. So this gives me a z-score of -2-ish for the data that it started with. And then we'll need to do the same thing over here on the right. So this sheet right here has two parts. There's if you're not given the sample data, you're just given the sample mean, size, and standard deviation. Or if you're given the sample data, where you have to plug it in like I did in that previous example. So we also want that test statistic down here. So row 19, column I would type the same thing, test statistic, oops. Comma Z equals, and then let's make that column a little bit wider. And in the next cell, I pretty much do the same calculation, equals, parentheses, and it's always the sample mean minus the null hypothesis mean, close the numerator, and then divide by the standard error, which is the standard deviation of the sampling distribution. This is the second standard deviation. And I should get the same number as before, but instead of being, it's calculated based off the sample list over here. And it's not absolutely necessary to have that in the z-test, but it is necessary to have it for a t-test. So you should double check. I think your t-test tab should have that test statistic here. And that is the t-score for the data. And I think I did put it in the proportion test. Yeah, there's a z-score for the proportion. T and Z are good. Okay. Sorry, Charlotte, I didn't understand your chat message there. You're welcome, Eileen. Yeah, so now, Eileen, did you put that in your Google Drive this time, or is it in Excel? Both sheets. Oh yeah, thanks, Charlotte, yeah. So you can use this spreadsheet during the test. It's pretty helpful for the calculations, but you should definitely draw it out. Yeah, so to find this in your Google Drive, sit down and take the test. It may appear in your top bar here. Otherwise, if you jump over to recents, you could find it, or if you just search for hypothesis, it should pop up, and then you should be able to get back into it. Then it's just a matter of picking the right tab in the sheet and then picking the right part of that tab. Okay, so I got about enough time for about one more question before I got to get back to grading. Is there something else you all want to go over before we break? Okay, sounds good. So remember, when you do sit down to take the final, just make sure you have a nice, clear, clean, quiet space to work in, well rested, well fed, and have a nice organized set of notes nearby to look at, maybe the spreadsheets, this one, and then if we go back to the home page, there were two different spreadsheets I had here. One for confidence intervals for means and the other for confidence intervals for proportions. So those would be two to have ready to go in your Google Drive when you take the test. So I would open them ahead of time so you're not searching for them during the test. So just get all your stuff ready, take a quick walk, and then kick butt on that test. And then on the test, there's a few questions where I'll ask you, where'd my sample stuff go? I lost a tab somewhere. Over here, no, over there. I don't know where it went. There'll be a few questions like the one we just did about the test scores, where I'll ask you to state your conclusion in words and to draw a picture and get me that picture. And you can, there's a button to do it there at the time, or if that's too much trouble, right after you take the test, take a picture of your notes and message it to me or email it to me so I can look at it when I regrade your test. So the first test score you get will be a little lower because there's a few parts that I need to go in and read and grade based on your drawings and your writing. And hopefully I will get to that within 24 hours of you taking the test. A bunch of people took it yesterday, about a third of the class took it yesterday. So I've been working on grading those in addition to catching up on corrections. Okay, well, take care, do good math. I will see you all in the near future. And if not, have a great summer. Bye-bye.